We've looked at hydrogen, the formation of hydrogen molecule from an energy standpoint. So here's our reaction. Now let's look at it more from picturing what these orbitals look like. So here's our reaction before, after forming our H2 molecule. This is a bond. We've already described this as a sigma bond. And we can now look at these orbitals as pictures. Now, as it turns out, when we talk about orbitals and electrons, you'll encounter ideas like the wave-particle duality. So these orbitals have wave-type properties. When I say wave, I mean they fit mathematical equations. And because these orbitals fit mathematical expressions, we can apply mathematical operations to these different atomic orbitals. And that means we can do things like add and subtract them. So this is a little bit odd, but bear with me. So let's talk about making our sigma bond. So what we're going to do is we're going to look at a 1s orbital, and here's a 1s orbital, and that dot's meant to represent the hydrogen nucleus in the middle, and there's an electron that's spinning around this in some orbital looking like a 1s orbital. Now, we're then going to mix this with another hydrogen atom, which is in its electron sits in a 1s atomic orbital. And we're going to add them together. We're going to bring them together in space. And as they get closer and closer, there's one of them, they start to occupy and share the same space. And as they overlap, this region in between the two nuclei, it kind of blends together. And what we end up getting are two hydrogen atoms. And we get this exaggerated bulge between the two hydrogen atoms, and this is now our new molecular orbital. So we've taken two atomic orbitals, we've mixed them together, we've added them together, and we've gotten a new molecular orbital. Now, of course, we're not done, because if we take two orbitals together, we're going to have to get two molecular orbitals. We're only showing one. This is a picture of the sigma bonding orbital, that lower energy orbital from our energy picture. And if you look, this is kind of a representation of where do the electrons reside. They're almost exclusively between the nuclei. These are really low energy electrons, are happy to put a term on it. And so those two electrons are low in energy, and this is a bonding orbital. Okay, what do we do with our sigma star? So again, we're going to take our 1s, and we're going to mix this with another s, but actually we're going to now subtract them. I wrote addition. This is actually going to be subtraction. Let's mark that out. Well, we're going to subtract these two orbitals. Now, for me, the idea of subtracting an orbital is really a little bit too abstract, because orbitals are hard enough to think about to begin with. So let's think of it differently. Let's think of it, instead of as subtracting an orbital, let's add the negative of this orbital. So here's our hydrogen, and now we're going to add this to the negative of our orbital, and to show that we're dealing with the negative of an orbital, let's make it shaded. So now we're going to bring these two orbitals close together in space, just like we did these two. And so we're going to have our H. Great, there's one of our 1s's. And now it's going to come in close proximity with and overlap with the negative of that orbital. And where these overlap, you're going to get a destructive interference where they're going to cancel out in between. And the resulting orbital that we're going to see is going to kind of look like this, where they've canceled out in between. And where we have no overlap between orbitals, we call that a node. And that's a node in between. So this looks like two orbitals. It's actually just two halves of a single orbital. This is now a new molecular orbital. Specifically, it is the sigma star. So we've mixed our two orbitals. We mixed them two different ways, and we mixed two orbitals in, two orbitals out, two molecular orbitals. Now, where are the electrons? They're occupying one of these two spaces. And if you look, these electrons primarily sit outside the two nuclei. They are not as happy. They are in a higher energy state, and therefore that's what makes these electrons less stable. And that's why we fill the sigma, the bonding orbital, first, and we fill the sigma star second, only if we have enough electrons. So this is a way to look at two different pictures, two different representations of these molecular orbitals. We already saw them from an energetic standpoint, and now we're looking at it more from a pictorial standpoint to gain better understanding of what goes on in covalent bonding.